Now we are going to see one more a concept in quantum mechanics, that is expectation value. Last time we have seen this a Schrodinger's equation, then a concept of operators. So there is one more concept, that is expectation value. What is meaning of that expectation? Word expectation. So that the word expectation is something is to be happening. Something is to be happening. For example, you will be getting promoted. So expectation means you will be getting promoted, or you have appeared for the examination, you have solved your question papers, and what is the expected result? The expected result is that you will get passed with a distinction. So this is the actual meaning of this expectation. Okay, now here in quantum mechanics we are going to see what is the expectation value of a dynamical variables. So it is expectation value of what? It is expectation value of a dynamical variables. So let a particle is moving from one dimensional x direction, and which is represented as a psi of xt is its wave function. So this is the wave function which describes the motion of the particle, and it's a psi star xt is its complex conjugate. It is a complex conjugate. And a dynamical variable is x. X is a dynamical variable. Means the particle is in between, say, x and x plus dx. Then the particle is in between x and x plus dx. Then where it should be? So the answer is in the probability. And therefore, in quantum mechanics last we have seen that probabilistic meaning of this probability. So this value of that finding the particle in between x and x plus dx is applying. We know that probability density is equal to this psi star, psi x psi star, and therefore the probability in between the x and x plus dx is given as so this p of xt is equal to this psi star dx, means the probability in between these two. And this dynamical variable, in classically how we taking that dynamical variable, suppose there is one object or a ball, and you are taking the reading of that small ball provided you in laboratory, and you have taken 10 readings, and the average value of this diameter, suppose d average is equal to d1 plus d2 plus d3, like that you have taken 10 readings, and therefore the average reading is d1 plus d2 plus d3 plus d10 divided by 10. So these are the 10 readings. So this is what we have did in our laboratories. So this average diameter is this much. Here the particle is in between x and x plus dx. Exactly we can't say, and therefore the answer is in terms of the probability, and therefore the expected value of this x is quantum mechanically is represented by symbolically is like this bracket. So the bracket expectation value we read as expectation value of x. Write here as a bracket x, but read it as expectation value of x. So this expectation value of x is equal to the integration x into a probability of finding the particle in between x and x plus dx into x. So it is the multiplication of the x into probability of the finding the particle in between x plus x and x plus dx divided by a probability of finding the particle in between x and x plus dx. But we have defined that a probability of this one, and therefore it is nothing but the x into psi star s psi dx divided by the integration psi star s psi dx, and therefore it is written as the integration a psi star x psi dx divided by integration a psi star psi dx is equal to, so this is the definition of expectation value of the x. Here, if the wave function is normalized, so this psi of xt is normalized, and therefore we know that normalization condition psi star dx is equal to 1, and therefore this denominator is equal to, this is equal to 1, and therefore expectation value of the x is equal to integration a psi star x sr dx if the wave function is normalized. So this is the dynamical variable x. If in general a dynamical variable is represented as f, f is any dynamical variable, not a position, momentum, or any dynamical variable in quantum mechanics associated with a wave function psi of x, and therefore the dynamical variable x, expectation value of this is equal to integration a psi star f psi dx divided by integration psi star psi dx. Again here, if your the wave function is normalized, then according to the normalization condition psi star psi dx is equal to 1, and therefore expectation value of the f is equal to integration psi star f psi dx. So this is the expectation value of any dynamical variable. Last time we have seen a momentum operator, and how will momentum is a dynamical variable, then energy is again the dynamical variable, and therefore expectation value of momentum can be written as, so expectation value of the momentum is equal to integration a psi star p operator into psi dx, considering the wave function is normalized. Okay, and therefore this operator is what? Is equal to integration psi star into minus pi h cross dou by a dou x of psi dx if wave function. So this is what? This is the expectation value of the p. Now similarly the value expectation value of the energy is equal to integration a psi star operator of energy operator psi is equal to this, is equal to integration psi star is pi h cross dou by 2t. When we differentiate the wave function with respect to x, we will get the momentum operator. Differentiate with respect to t, we will get the energy operator, and therefore this is the psi dx. So this is the energy operator. Means any dynamical variable, so this is the dynamical variable, can be written in terms of its operator. So any dynamical expectation value of the energy, expectation value of any dynamical variable can be represented in terms of its operator. So this is the connection between this very rich expectation value concept. So any dynamical variable can be represented its dynamical variable in its expectation value in terms of its operator.